Okay, so start saglit lang, mabilis ang solve. So refrigerating cycle, no? Automatic, meron tayong 4 na components. Meron tayong evaporator, tapos after evaporator meron tayong compressor, no? After compressor merong condenser. Okay, after condenser meron tayong expansion valve, no? Okay, so sabi evaporating temperature is what? -5 degrees Celsius, no? Condensing temperature is what? 40 degrees. Refrigerating capacity, pag sinabing refrigerating capacity, dito siya take place sa evaporator, no? So meron kang 1 kilowatts dito. Okay, so at 40 degrees, remember, ang pumapasok dito is what? Ang lalabas sa evaporator is saturated vapor. Okay, dito paglabas ng compressor, saturated vapor. Pag lumabas ng evaporator, paglabas ng compressor, this is your superheated, no? And leaving the condenser, ano to? This is your saturated liquid, no? Saturated liquid. Okay, sa expansion valve, kung ano yung pumasok dito, siya din yung lalabas dito na enthalpy, no? So iisa lang siya. So sabi 40 degrees HF here is your saturated liquid, no? SL or HF is what? 238.5 kilojoules per kilogram. Sa -5 degrees, yung HG mo or your SV, saturated vapor, which is your HG, equals 349.3, okay? 349.3 kilojoules per kilogram. Okay? Enthalpy at entrance of condenser. So ibig sabihin, leaving the compressor, entering the condenser, meron kang superheated enthalpy, which is 372 kilojoules per kilogram. Okay, so again, if this is 238.5 and expansion valve undergoes isenthalpic process, meaning constant yung enthalpy, therefore you would expect what? An enthalpy here, H4, enthalpy by H4 equals 238.5 kilojoules per kilogram. Usually dito kasi mixture minsan lumalabas, no? Depende sa quality. If your quality is equal to if your quality is less than 1, then you have a mixture, no? And most of the time yung quality naman natin is less than 1. Okay, so moving on, refrigerating capacity natin is 1 kilowatts. This time kunin lang natin yung COP. Remember COP? COP is what? COP is usually expressed as a ratio between tons of refrigerating capacity, or tons of refrigeration or refrigerating capacity over the work of the compressor. Okay? Also, kung makikita mo, no? Simply dito lang siya nagma-match between the two, no? So, kung gagamit ka ng enthalpy, okay? Kung gagamit ka ng enthalpy, magiging ano siya? What? Magiging, let this be your 1, 2, 3, and 4. No? Okay. So, H1 minus H4 over H2 minus H1. Okay. So, kung may ratio ka na, since ito naman is naka-COP na, and the tons of refrigeration is in 1 kilowatt, no? 1 kilowatt over the work compressor. Ano ba sabi niya? Walang sinabi kung ano, no, yung work compressor is in HP or kilowatts. So, assuming in kilowatts. Ano ba H1 ko? 3. Remember, COP is dimensionless, no? Kasi it shows if either efficiency or the ratio between the refrigerating capacity over the work of the compressor. So 238.5. Remember, this is kilojoules per kilogram over 372 minus 349.3 kilojoules per kilogram. Yun, no? So cancel. Remember, this is dimensionless. You can shift solve. You can find the work of the compressor is in paano ba to? .3 minus 2.8. Minus 3.3. Okay. Pero equals ano yan? Refrigerating capacity is 1. Let this be, and let this be X. Sorry. Let this be X. No? Therefore, X mo would be what? 0.20487, I guess. 0.20487 kilowatts, no? Or approximately what? Approximately 204, no? 0.87 watts. Or if you want, just convert them to HP, no? Okay. So yun na yung final answer. Second question for the refrigeration system. When talking about reverse Carnot cycle, remember the COP, Carnot cycle pertaining to the theoretical, no, refrigerating system. COP of the reversed Carnot cycle is equivalent to difference between the maximum, is the ratio between the minimum temperature over the difference between the maximum and the minimum, no? And also COP pertaining to the figure, going back, we have an evaporator, we have the compressor, condenser, thus we have the expansion valve, no? Again, COP is what? COP is the ratio between the refrigerating capacity exerted through the evaporator over the work of the compressor, no? So in this case, this is your TR over work of the compressor. Okay? Since in this case, sabi, heat rejected to the condenser, ibig sabihin, ito yung reject na heat sa condenser. Remember na you are putting in work and putting in energy sa evaporator. That means, no, that the Q rejected is always equal to the work of the compressor plus the tons of refrigeration or the refrigerating capacity. If this is the case, then pwede nating sabihin na we want just the TR, no? And we want the power input. So we can use these two, no? Paano natin gagawin yun? We just want the TR. Simply, TR is what? QR minus work of the compressor. So pwede natin sabihin na Q rejected minus work of the compressor tapos work of the compressor, no? Okay? Yan. So, kung gagawin natin to equation, itong buong to, no? Itong buong equation na to via the COP. The minimum temperature is what? It's negative 25 plus 273. Always in absolute temperature, no? If the temperature is a standalone sa either numerator or denominator. Pag difference naman, kahit hindi mo na sa absolute kasi hindi nagmamatter. Say, kunwari, 25 degrees Celsius minus 3 degrees Celsius. This is the same as pag mag plus 273 ka dyan and plus 273 ka dyan. Maka-cancel lang din sila, no? So in this case, we have what? 72 minus 25. Okay? Kelvin to. Equal siya sa, ano sabi? Kilojoules per minute. So if that is in kilojoules per minute, let's just use kilojoules per second, no? Para maging kilowatts. In this case, pwede natin gawing 6,000 kilojoules per 60 second. Okay? Minus the work of the compressor over the work of the compressor. Shifts off mo yan. Work of the compressor is what? Okay, ito yung values. Okay. 25 plus 273. 72 minus 25 equals, sabi, 60 minus, this is the work of the compressor and the work of the compressor. What is X? 28.116, no? Work of the compressor is 28.116 kilowatts. Okay? Matik, gawin mo lang HP. Every 0.746 kilowatts, you have 1 HP, no? So, ilan yun? $37.69 HP, no? So we have 37.69 HP or 37.7 HP. Probably 38 na. Sure, no? But yeah, that's the value. Okay. So again here, recap lang. The work of the compressor, nag-exert tayo. Evaporating effect or the refrigerating effect. We're also exerting energy in. So the heat is always going out, okay? In, and then out.